Hi everyone. In this video we will continue the implementation of our end-to-end test from last video. So if you remember well where we stopped, right? So we basically implemented the configuration of our mock server. We also did we defined the expectation here for our mock endpoint itself. But if you remember, the biggest problem here on our test was that the test is like a black box. We cannot predict what kind of detections we are going to send or we are going to generate, and we cannot test, for example, how many detections were generated and sent to the API. So we could not like validate this, right? So it's not ideal, right? So for that, and this is so because basically the design of our application of our code is not really ideal. So if you remember, like the code inside the fake detector is really complex. So it's doing a lot of things, and for that we are going to break it down a bit. So we are going to break down our detector in three steps. So first we are going to have one place where we are just going to generate triggers, or we will create triggers for a generation, for a detection generation. Then like let's think about all those steps like event based. Okay, so every trigger will create one event, right? So let's say there's one event here. So trigger, we can say like it's going to trigger something, for example, like every half a second. Then it generates a trigger, the trigger generates one event. The event comes here, and this component consumes this event and generates a detection. Then this generates another event, and which could be a detection, and this other component is going to listen to this event and call the API. So it's going to process the event. Okay, so one event coming from here, the event is being like transformed, or like we get like a trigger, like whatever, just a ping, right? And then we transform this ping into a detection, generate a detection, random detection right now. And then we come here and we basically get this detection and make the call to the API. But we are going to break this down everything in three different pieces of code, because everything now is inside the same class and it's not really ideal. So let's start first with the trigger itself, right? So since I mentioned about events, and why I mentioned about events is because I want to use a library which we can implement, or we can use one implementation of the observable pattern. So if you Google it, you can have more details, but observable pattern is basically a way for you to have some kind of, here in object-oriented programming, you have an object which can be observable. So it means that other objects can observe this and can like react to some specific behavior, some specific event in our case. Okay, so we are going to use, there are like some libraries for you to do this, to use it like this reactive approach in Java, like RxJava, Mutini, and Reactor. Since we are using Spring, and we will use Reactor later on the Spring Web Flux, we will be using Reactor right now. Okay, so before I start to explain or to give the idea of Reactor, let's just import Reactor core into our dependency here. So build, we don't need to add a version because this is already part of the whole Spring ecosystem, so the version will be already added by us, the ideal version, or the most up-to-date compatible version. We added that here, automated testing. Okay, so now if you look at it, if you come here, there are two types which we can use. Mono is one type of the Reactor inside the Reactor, and we also have Flux. Mono and Flux. Okay, so what's the difference between them? Mono is one type of object, one object which can emit 0 or one event. It can also generate one error event, and it can basically start and complete. Flux can emit 0 or infinite events. It can also emit an error event, and it also has to start and may complete, right? So mono will, as soon as the mono generates 0 event, it can say, hey, I may generate an event, right? A mono type. and says, hey, I generate one event. After generating this event, I will automatically complete, because Mono is supposed to generate maximum at most one event. Mono can also not generate anything and say, hey, I have no event to generate, let me just complete. This is also doable. Mono can try to generate one event, but instead it may fail trying to generate this event. So it throws, not throws, but it generates one error event. Flux can do similar, but Flux can generate events for like days until it completes. So this depends a lot on the logic of the Flux itself. Let me show you some example, okay? So Mono, how you create a Mono, right? There are multiple ways. You can create like static Mono by using just, for example. You say, hey, just 10. This will create for us a Mono of 10. So it means that Mono. So if you come here and say Mono dot on next, do on next, so you see that the type which you're going to, is going to be consumer of integer. So the value here is going to be a integer, right? So that's the event which will be published. And when you do a subscribe, you can, for example, just subscribe to it. I will explain what subscription means here. But you can subscribe and also pass, for example, like one callback for when there's an event published to react to one event, and also can react to the error here. But there are many ways for you to react to one event. Like as I said, do on next, it's a way to react to one event. Do on error is a way for you to react to an error. And do on success, for example, when the Mono completes successfully. So yeah, when it completes, but like without failing, that's what I mean. One important thing, when you create like a Mono, for example, or a Flux, by default this is called code observable. What does that mean? It means that it's not going to produce any event until you subscribe to it. When you come here and say mono.subscribe, then this event is going to be published. Published where? In the chain. Let's think like, for example, map here. Let's call this variable I, and if you call here since.print I, so when you call this, not map, let's do on next, because map needs this to be transformed. So map is a way, is like stream. Like when you think about Java, stream is the same concept. Okay, so you have I, and then you can say I plus 10. So this will transform the event, and this event, or the transformed event, is going to be passed to the next one. So you can print. If I don't subscribe here, nothing is going to happen. So nothing is going to be printed. It will just print when I call subscribe. Okay. So idea here is not to give a full like introduction about Mono, Flux, or the whole Reactor, but we will talk about this in the future. So now we just need to, that's the basic you need to know for us to use it. So I'm talking about this because if you go and you see what I mentioned before, I want to create a trigger which will basically trigger something every 500 milliseconds. So it will trigger one event, and whoever wants to say, hey, I want to do something periodically every 500 milliseconds, boom, you can use this. We could also have done this with the scheduler, right? With the Quartz or something like that. But I want to have this more flexible because I want to override this pattern on the test itself. Okay, so that's why I'm using Flux. So let's go to our code, to our test. To our configuration here. Let's start to write our code. So first I will create a bin here, which will be a flux, public flux of long. I will explain why this is a flux of long. And here I will call trigger generator, or just trigger. Detection trigger. So here what I'm going to do, so this flux is basically going to generate one event every 500 milliseconds, every 5 seconds. Okay, so how do I do that? There is a simple way for us to do that. So there, like very basic way, we could come here and say, hey, flux create. So I can have one object here called sync. So if you come here, that's a consumer of flux sync. So this sync is an object which you can use to emit events. Okay. So if you go to our detector, what's the rule which we use to process an event. We come here, we do like a while is alive. We could copy this, okay? And we could do something like this. So every, it's called whatever, we don't care about it. So every time we do a while, and we iterate through the loop, and we sleep for half second, we can come here and say sync dot next, and we can like send any event here. The value here of the link of the long is not important to us. And here, if there's any error during the sleep itself, we can throw an error. Not throw an error, sorry, we can emit one event of type error. That's one thing we can do, but it's really not good, because first we are doing a thread sleep, and doing thread sleep, unless you're doing this for testing or like for demonstration purposes, is really bad. So there's a better way for us to do it using Reactor. You can come here and create a mono delay. So what this mono delay is going to do? It's going to, so if you see mono delay returns a mono of long. It's basically going to generate one event of type long, which I really don't remember what kind of value this returns, but for us it's not really important, just important that it's a trigger, it's one event, right, which we can react and do something about it. And it will return, or it will like emit this event after a specific duration, which is the delay which we are going to provide here. So we come here and say duration of 500 milliseconds. So there will be one event, right? So now, how do I do to transform this event into multiple events and like a mono to a flux? You can, in our case, which makes sense, you can repeat them. So if you repeat this event, it will transform this mono into a flux, because it will run many times. Fine, perfect. That's it. We can, for example, come here and say, hey, let me, like here we have like a while true, like a while current thread is alive. But to be honest, this code doesn't make much sense in the end, because if the thread is not alive, how the thread is like, if the thread is running this code, for sure the thread is alive. Okay, so there's no reason for us to check, hey, the thread which is running this code is alive. Yes, for sure it's running the code. So that doesn't make much sense for us. Okay, so let's just repeat them every time. So every time there is one event, so like there's 500 milliseconds, the event is being, let's say it will generate first one long. It will come here and say, oh, please repeat 100, like half millisecond, repeat, half millisecond, repeat. And then if whoever comes here and say do, for example, a map of, I don't know, I, which is the value of long, this code will execute every half a second, or around half a second, okay? Because we are basically delaying this event many times. And that's like what we want. That's just a trigger for us to generate. So that's the first part which we needed to do, okay? So the trigger is there. Now we need to generate a detection based on this trigger. So how do we do it? Let's create now a bin of public of flux of detection. So the flux now is going to generate a lot of detections. Detection generator. And what we are going to do, we are going to receive a flux of long. Okay, so flux long, detection trigger. What do we do here? We return, so basically we get the detection trigger. We do what? We do a map because we want to transform, right? So here we receive the long, which we really don't care about this value here. So I will even call this true underline, so it's not important to us. And what I'm going to do is, if you come to the fake detector, I will generate a detection. That's exactly what we want to do. I will just come here and generate a detection. We need to import, we need to have the random here, right? Var random, new random. That's it. So now the detection generator is also working fine. Now we basically have to process the detection itself. So we need to call the API. Now we have to do some small change. Not that we have to, but I would like to do one change on the detector. Before that, let me just clean up, right? So now what we are going to do. Here we need to receive the flux of detection. So detection generator. So let's import, let's add this as a property into our class. Detection generator, this here. Now what else we do? We can come here and say, let's remove all this code, not all this code, but let's come here and say detection generator. So every event on the map, what am I going to do? So you come here and say, so here we receive the detection, right? Let's call the processor dot on event. So we send the detection. We can also do this on the lambda here. And here I can do, for example, do an error. So it will execute a function when there is an error. We can do it, but I will show you a problem on error. So we can do that here, and then what we can do, we can subscribe. But since we are running this code inside our executor service, I'm not going to subscribe, because subscription will basically free or release the main thread which is running this code here. And that's not what we want to do, because we want this thread to be blocked on this execution. So we basically can come here and say block last. So it will block until the whole flux is completed, until all the events are being generated. So we can block last here. Yeah, but there's one problem in this code. What problem is, so if you remember what I mentioned, like for example in the flux generates one or infinite events. It may also generate an error, and it can start and complete. When a flux or a mono like emit an error, it automatically completes. So there's no way for you to, for example, in a flux or like a mono, let's say a mono. In a mono you cannot produce 0 event, then error, and then 1 event. You cannot do it. After error, the mono or flux is completed. You cannot generate anything else. So, and that's not what we want, right? Because if there's an error during this generation of the detection, we want basically to continue, right? So there's a method which we can do to skip the errors, and we can continue the processing of the flux, or generation of the flux. We can have here on error continue, we are going to have a exception here and another object, which I don't care about which object is that, and I will call processor dot on error, and then I will pass the exception here, and that's basically it. Okay, so there's a messy code here, because we have the executor service submit, and then we have here, and we block the thread. There's a better way for us to do that using the reactor. So you can come here, copy this code. Since you have a flux, you can call the method subscribe on. And here, basically, subscribe on is going to say, hey, I want you to start to generate the thread, the events here, like the detections. I want you to process the events here, and I also want you to handle the errors, but I want you to do everything on the scheduler. So schedulers, you can call schedulers dot from executor, which we already have the executor service here. We can do it. So it will basically create a scheduler based on this executor service. So, and now we can subscribe, or we can subscribe. So it will run our code inside the processor itself, which we have. Not the processor, the executor service. One thing though, very important, when you call subscribe, this will return to us a disposable. What is a disposable? So a disposable is an object which you can cancel, like similar to a future here. So if you can come here and say, hey, please dispose, so stop to run this task. So when you subscribe, you basically create a task. So let's change a bit our code. So instead of future here, I will change this to disposable. Disposable, here I'm going to use disposable. Here the same, we can call dispose if anyone asks this fake detector to stop. Here we can come and check just if this is not disposed. So if the code is here and it's not disposed, then it's running. Okay, I think that's basically it. Okay, let's just clean up that thing here, the imports. What else? We could also do some change on the interface of our processor itself, but let's keep it like this for now, not to make it too long this video. Okay. So what else do we have? Okay, now we need to also have here to inject some final flux detection generator, and we will provide detection generator here. What else? Most probably have test also broke. Yeah, as I imagine. So let's pass here like flux of empty. So a flux of empty is like flux which doesn't emit anything and just succeeds. this test for sure will block, will fail. But let's come back to this later. Okay, let's just make sure that the compilation is running. Now let's come here and let's run our test and see if this is still working. So we haven't changed anything in the test, right? So we have just changed the code. You see everything is still working fine, right? So we are making the requests are passing great, but still the problem is, so the problems which we had before is basically the same still. So the events which we are generating, as you can see, they are random. Now we want to predict, we want to tell like to our test to generate exactly the detections that we want. And how do we do it? Well, let's create a new class here, like static class inside the test, because I don't want to have this exposed somewhere. I can even make it private. I will call this config, or yeah, internal config or test config, whatever, test config. Okay, so I'll create this class here. I will add this test configuration. I could have this class externally, but since this is going to be used just for this test, I will make it here. Okay, test config. I will create a bin which is of type flux detection. So detection generator. This is basically going to return to us a flux of one event, which is going to be a static one. So I come here, public static detection default detection. Okay, so this will be in, new detection UID random. Then what else we have? I always forget about it. UID plate speed and instant. UID plate speed instant. Okay, so we have a default detection here. We are basically going to generate this default detection. So that's something which you can predict because we know what's going on. So now how do we tell Spring to override this? We can come here in the Spring input test and we can provide classes for it, in which we want to Spring to use to start our application as well. So we come here and say test config. Config or configuration? Test configuration? Test config. Oops. I think we need to make it public, right? Do we? Config. Yes, that's it. So that's basically it. Okay, so now let's try and run our test again. What's going on? Spring caused by. Okay, now there's another thing which we have to do. So by default, Spring does not allow this overriding these objects. So we need to do one small change, which is spring.main, or in fact we cannot do it here. We have to do it on the application YAML itself. So Spring main, then we have override. Let me check. Google it. Override Spring override being property. This one here. Yeah, this is the place. So no, yeah, this. So main allow being definition overriding. That's exactly what we need to do. Then we define as true. Okay, but instead of doing this, let's do the following. I don't want to do this on this main application, so I will just create a new one here. Resources, and then I create a application YAML file, and I will just have this there. Let's try to run again. There's another thing right now. What's going on for OAT and applications. Failure to process class detection generation. Okay, cannot register being definition. What cannot register? Detection generator. Let me check. So detection generator, that's this one here. Let me just confirm that this is related to that. Test should be, and no. I guess. Oh wait. Clean up that here. No. Okay. Let me clean up. Remove everything. See where this started to fail, because I probably did something wrong somewhere, which I don't remember where. Let's see. Start application to test again. Yeah, it's running. So it's something which I did here. So let's move out this test config out from the class itself. It may be related to that. Let's come here in the test and create here a class called, or maybe the test name itself is wrong. Let's call it config. If the test is the name is conflicting with something. So config, and let's run this again. Nope, never mind. Let's remove that from here. Let's create the class on equipment or config.equipment test config. Let's copy this everything from here into there. Let's also add the test configuration. And now what we will do is to add the class here. Equipment test config class. Let's run the test. Boom. Is it? So it's running, seems like, or is it? Has it failed? It's a bit awkward. This. So yeah, it's a bit strange. No being okay, let me stop again. It's already still running. Caused by Spring test context failure to process test class detector application test for AOT. What's the problem with this class? Oh wait, this class is not public here. Never mind. This one here, there's something which I'm doing wrong. Public being, we have the right import, not a problem. Let me see if this makes any difference in here. Yeah, there's something. So for some reason, this test application YAML here is not working. Just injecting this on the test. So let's not spend much time on this right now. I will check that later. Then on the next class, next video, we can fix that. So maybe even this was working here from inside. So let me just confirm. Let's keep that here as we were before, as we had before. And here I will delete this. Now let's have this importing the class config from here. Let's run the test. Yeah, now it's working. Okay, so I will take a look and see why this is not working, because having this application YAML inside the test resource should do the trick for us, should do the job for us. But all fine, okay? So now you can see that everything's working fine. And if you go to the test, let's run the test again. You see that we are generating only one event. So there's only one event, which is speed 100 and equipment ID and the ID that we expected. So let's do one thing. But in fact, it's generating one detection, but it's calling the APIs twice. Why? Because if you remember, we are having by default the number of lanes equals to 2. So let's do some overriding here. So let's come here and say that for this test, we want to have the equipment dot ID. We want to have this like new one. Let's also add that here. So we say private final UID equipment ID. So we generate one per test. So this dot equipment ID is going to be a uid dot random. Okay, so here we will add the equipment ID to a string, and we will also set the number of lanes to 1. So we don't want to have this mess of having two at the same time running. For us, it doesn't make much difference right now. But if you want to test, we can also do it. Okay, let's just keep it 1 for now. And now what we want to do, so ensuring that we, knowing that we have this equipment ID, knowing that we have only one lane running, how many times would you expect these endpoints to be called? So first we can add the validation of the body, right? Because now we know the body which we are going to call. So the body we will define here expected request or expected body is from the type of external detection registration. That's the type which we are going to do. So we have the UUID, the equipment ID, and the double speed. So the ID of the detection, we can get it from config.default.id. That's the default we are going to generate. The equipment ID, we can have this from the class itself, from the object, equipment ID, and the speed, we also get it from the config default detection.speed. Now we know the expected body, we can confirm that here. Let's set, and let's run, and let's see that if the data we are sending to the API is correct, as we expected. As you can see, everything's fine, no error. So there's only one event sent, and this event matched, and then we received a 201. Okay, totally fine. So just for you to understand it's really working, if I set here 50 instead of the default from the default detection, which is 100, it's going to fail, not the test, but at least here it's going to fail. Okay, so but we want our test also to fail, right? So we want the test also to fail. So we need to do something. So here, when we create like client and server and when and then we call respond, this returns to us an object of type, I think, what's the type? Respond, it's expectation, yes. So var expectations. So we have expectations here, it's an array. Now, after running and sleeping for 5 seconds, for example, we can do it like much quicker right now, so half a second, because there's only one event, which we know. Now we can come here and say, hey, please, client and server, verify that expectation 0, like the first expectation, we just have 1, right? So if this expectation here runs exactly once, so I want to be sure that this API was called exactly once. Oops, this is failing. Why this is failing? Verify, cannot resolve, wait. Expectation ID and verify education times. Oh, we need to get the ID, right? Not the expectation object. Now we run and everything's fine. But let's change, for example, our speed to 50 and see how this will work now. Okay, now you see that our test fails because like we are expecting this API to be called exactly with the value which we expect, but it doesn't happen. But when we call the client and server verify, this verify if the API was called, how many times, the number of times which we expected. If it doesn't, then it fails. So we see that the test is really breaking, and that's exactly what we wanted. So in the end, that's exactly what we wanted to achieve. Okay, so there is still a problem or some problems, right? But we cannot solve everything in one video. The problem right now is that we have to sleep here still, right? We would like to have a way for us to not sleep that much, or like to have a way, like how, for example, how do we ensure that if I come here and start the starter, what if I want to come here and do a stop? I don't have a method to stop the application itself, right? So that's kind of bad. Also, yeah, I think that's one of the biggest problems right now, okay? But as I mentioned before, we cannot resolve everything in one video. Let's stop for now. We did what we wanted, so at least now we can verify that our application is running and sending data to the API. Okay, so next video what we are going to do is we are going to do the less small changes on this, so we are going to be able to start and stop the server properly. using the code which you already have, and then the next video we will start to move to the next tasks. Okay, I hope you liked it, and see you in the next video. Bye bye.